Hi, welcome back. All right, so in this video, we're going to continue our discussion of a horizontal asymptote. So we know that because if we look at this function right here, as x goes to infinity, that is telling us that this is talking about the end behavior of the horizontal asymptote. And in our last video, we talked about the phrase, what matters most. And that's really what we want to look at. What matters the most on top or bottom? If we look at the numerator here, I have e to the x, 3x, and minus 4. Well, which one of those matters the most in the big picture? You should say e to the x, because e to the x is so much bigger. It grows so much faster than all the other things in the numerator. On the bottom, be very careful for the bottom, square root of x, 4x, and 7. Which one should matter the most? Hopefully you said the 4x, because that's x to the 1/2. That degree is less than x to the first. So this is going to become e to the x over 4x, 4 times x. And now we just got to kind of think about this for a little bit. Now, even though I can't cancel out the x's right here, later on, we're really going to learn how to solve a problem like this using something called L'Hopital's. But honestly, we can just think about it. Which grows faster? E to the x, which looks like this, or 4x, which looks like a line. Well, which one grows faster? E to the x does. And since e to the x is on top, we're saying that the top is going so much faster than the bottom, 4x. So what does that do to the graph itself? Well, hopefully kind of figure out, well, if the top is getting bigger than the bottom faster, this should be approaching infinity. Because even if I did like 1 over 1, the next one could be like 2 over 1.1. The next one could be like 10 over 2. The top is just growing so much faster than the bottom that it's just going to grow without bounds right there. And we can do the same thing for number 11. Same thing, we're looking at a horizontal asymptote. And on top, now it's going to be kind of tricky right here. We have sine of x. Well, what does sine of x do? Well, sine of x just oscillates back and forth. Natural log of x does kind of grow, but a parabola grows much faster. So what matters most on the top, we should get that x squared. So I'm going to write this as a limit as x goes to a negative infinity of x squared. I should make that look a little bit better there. And on the bottom, again, cosine is just wiggly wobbly. It just goes between -1 and 1. We talked about this on the assignment from the other day. If I have that limits x goes to infinity of cosine of x, this does not exist because it oscillates. You might recall that from the day before. So that's just going to oscillate, which means it's not really going to help us out much in terms of growth. But x grows pretty quickly. So grows faster than cosine, because remember, because x just goes, it keeps growing, where cosine just goes back and forth. So I can reduce it. The limit as x goes to negative infinity of just x, and I can just plug that in, and I just get negative infinity right here. All right, hope you guys enjoyed the video, and I'll see you guys later. Bye-bye.